Welcome to Guide Guru. We hope this video helps.
You begin by locating the current direction or the velocity vector of the charged particle. Point your index finger that way. Next, extend your middle finger perpendicular to your index to represent the magnetic field B. Make sure it's comfortable and perpendicular. Finally, align your thumb so it's perpendicular to both fingers. That thumb shows the magnetic force direction on a positive charge. Once done, check that fingers form a right-handed set. This is the foundation for every example that follows. You now map the hand to real vectors. Rotate your hand so the index aligns with the actual current or velocity in the setup, and the middle finger aligns with the magnetic field vector. This may require twisting your wrist. If the entity is negatively charged, invert the thumb direction to get the force. When vectors have components, apply the rule to each component pair and sum results. This helps for angled fields. Make sure to visualize perpendicular projections when components aren't orthogonal. You finish by comparing the hand result to the algebraic cross product F equals QV times B. Compute or sketch the vectors to confirm direction and magnitude intuition. If the direction seems wrong, first check whether you use the right hand versus left hand orientation and whether the charge sign should invert the force. Make sure your hand wasn't mirrored by reflection. As a troubleshooting tip, always draw a quick 3D diagram or use a model. This catches common orientation mistakes.
Thanks for watching. Consider subscribing if we helped you today.